Alrighty, welcome back. Okay, this is going to make up a bulk of the things that you're going to see throughout the years doing these derivatives, but they don't usually do derivatives with just one term. I mean, that happens, but we do a lot of derivatives with sum and difference of polynomials. So don't overthink it. It's pretty straightforward. If you're adding two polynomials, you just take the derivative of the first, derivative of the second, add them together as is. If it's subtracting two things, it's to take the derivative, subtract the derivative, done. Um, Obviously there will be some catches here, but let me just give you a very simple question, right? What if I said I had x to the fourth minus 2x cubed plus 7x, right? So I'd take the derivative of the first one, which is 4x to the third. I would take the derivative of the next one, which is going to be negative 6x squared, and then take the derivative of the last one, which is plus 7. That's it. That's all you got to do. So pretty straightforward there, right? Now, there is obviously some catches that we're going to work with. So for example, this one right here. This one is one that everybody forgets how to do. They get really hung up on this one throughout the year. And so I want to make sure that we really talk about it and you really understand it. Anytime you have a polynomial on top and a single term on the bottom of the fraction, you should rewrite the fraction in separate fractions. That denominator gets applied here, and that denominator gets applied here, and that denominator gets applied here. The reverse is not true, though. If you have x over x cubed minus 4x plus 5, you cannot break this one apart. That one is going to involve something totally different that we'll get into way later in the year. For now, just know that this can be rewritten as x cubed over x minus 4x over x plus 5 over x. And we could do some simplifying there, right? We know that when we do this, we can rewrite x cubed over x as x squared. One of the x's cancel. 4x over x, well, the x's cancel, I just have minus 4. And then plus 5 over x, well, the x doesn't cancel here, but we could rewrite it as 5 and then bring the x up top and make it a negative 1. All right, so now I can easily take the derivative like we just talked about. The derivative of x squared is 2x. The derivative of negative 4 is a constant, so that goes to 0, so I don't have to worry about that. The derivative of 5x to the negative 1, I multiply the negative 1 to 5, so I get negative 5. Reduce the power by 1, so negative 1 minus 1 is negative 2. And then obviously we could rewrite that as 5 over, and then move the x to the negative 2 to the bottom and make it x to the positive 2. All right, for B, now a lot of people do get messed up on this one. They try to just like take the derivative of this, take the derivative of this, and multiply them together as the answer. And that is definitely not correct. We are going to talk about something in the next section to make that a lot easier called the product rule. But for now, we're just gonna think of other ways we could solve this. If I wanted to solve this, I would just need to take all this stuff and repeated distribute it, right? I'm going to repeat distribute here. So x squared multiplied by x becomes x cubed. X squared multiplied by negative 3 is negative 3x squared. And then we'll do our repeated distribution here. So 1 times x is plus 1x. And then 1 times negative 3 is negative 3. And now that's a super simple power rule derivative, right? The derivative of x cubed is 3x squared. The derivative of negative 3x squared is negative 6x to the first. I could just write x though. The derivative of plus 1x is just plus 1. And then the derivative of negative 3 is 0, so we don't need to worry about writing that part. Okay, continuing on this trek. Ooh, that's a crazy one. Again, mistakes you don't want to make. There are a lot of people who look at that and say, oh, isn't this just x cubed minus 3 cubed? And they solve that and they take the derivative. Absolutely not. The way that this is written, x minus 3 to the third power, really means x minus 3 times x minus 3 times x minus 3. So it's going to be kind of like B, but we're going to have to do two cases of repeated distribution. So I'm going to start by repeated distributing this piece right here. So I'm going to do the second two first. Okay, so I have x minus 3 in front. All right, x times x is x squared. X times negative 3 is negative 3x. And then if I multiply here, negative 3x is also negative 3x. I'm going to have negative 6x. And then I've got negative 3 multiplied by negative 3, which is going to be plus 9. Okay, now I got to repeat distribute all this. So I'm going to start with the x. X times x squared is x cubed. X times negative 6x is negative 6x squared. And the x times 9 is plus 9x. Okay, let's move over to the negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 6 is plus 18x. And then negative 3 times 9 is negative 27. That's a lot. Let's simplify what we can there. I'm going to highlight as I go. Okay, x cubed, that's it. There's just an x cubed. Nothing to combine with that. Okay, negative 6x squared, negative 3x squared. That makes negative 9x squared. Okay, and then I've got plus 9x and plus 18x. That's plus 27x. And then I got the minus 27 at the end, and I want to highlight it just so I have everything highlighted because I don't want to leave it undone. All right, now I can go through and take the derivative. Very straightforward once you get it simplified at the end. All right, x cubed becomes 3x squared. Negative 9x squared becomes negative 18x. 27x becomes plus 27, and then the derivative of negative 27 is 0, so it goes away. Wow, wow, wow. Okay. By the way, this one, wait in a couple units, a couple sections, you're going to realize, oh, that's actually really easy. We don't need to do all that, but it's good practice, good way to make sure we're practicing our multiplication skills so we can also take the derivative efficiently. All right, here we got this problem, which is, well, it is a single term on the bottom, which means I can rewrite this as two separate fractions. So let's just immediately start by doing that. 2x squared over, I don't want to leave it as square root of x though, right? We know that square root of x becomes x to the 1/2. That's how I want it written. Minus 3x over x to the 1/2. So now at first you might look at this and be like, wait, what do I do? There's like 1/2s and numbers and all that stuff, right? Let me just go back here real quick. Do you remember why this equals x squared? The reason is because you have x to the third over x to the first. And what we technically did in algebra is we did 3 minus 1, and that gave us 2. Here you had x to the first over x to the first. 1 minus 1 is 0, which is why there's no x's here. Here I have x to the 0. 0 minus 1 is negative 1. So it's always the top minus the bottom. So let's use that here to make this a little bit easier. If I do the top minus the bottom, well, I have 2. What is x? Sorry, what's the power of 2 minus a power of 1/2? So 2 minus 1/2. Well, that's going to become 4/2, right? Let's see, 2 minus 1/2 equals 4/2 minus 1/2. So yeah, 3/2, right? If you need to do the little algebra up there. So that becomes 3/2. Okay, and then here, 3x, so x minus x to the 1/2 becomes x to the 1/2. 3x to the 1/2. I don't know why I lost my x there. There we go. Sorry, I don't know where the x went. I just was thinking about doing the exponent and forgot to write the variable. Okay, so now I think I could take the derivative. Okay, so right here I've got 2 multiplied by, I'm going to bring the 3/2 down. And then 3/2 minus 1 is becoming 1/2. Okay, here I've got, bring the 1/2 down. And then 1/2 minus 1 is negative 1/2. Okay, so let's simplify what I can here. You can see that right here, these 2's are going to cancel each other out. So this really just becomes 3x to the 1/2. Over here, nothing cancels. I just got 3/2. Ooh, let's move this x to the bottom, right? It's x to the negative 1/2. So let's just put it on the bottom, make it positive 1/2. Then you could rewrite all of those as square roots if you would like. Most likely on an MCQ, that's how they would leave it. Now, again, let me just restate this. If this was an FRQ, I would want you to leave your answer exactly like this. They don't care on the FRQs if you actually simplify. Now, if it's an MCQ, you have to be able to find the right answer, right? So you are responsible for understanding how to manipulate the algebra. But if this is an FRQ question, you can stop right here and say, I'm done. That's a good enough answer, even though it's messy and ugly. The thing we like to say is you don't get style points on the FRQ, right? Just because you could take this and turn this into this doesn't give you any extra points on the AP exam. If you could just stop here, that's fine. You'll get full credit. If you can get here, you'll get full credit. But you are more likely to make a mistake from here to here than from just stopping here, right? It gives you more opportunity to mess something up. So just stop at the unsimplified version. All right. Let's kind of take together some of the things we've been learning. So this one wants us to write the equation of a tangent line. We did this in the last section, but it took forever. Remember, you had to use the whole rule to find the derivative. You don't got to do that anymore. Now you know the power rule, so this is going to be really easy. So in order to write a tangent line, let's go back and think about that. We need two things. We need a point and we need a slope. Well, the point is pretty straightforward. The point is 1, -1. They gave it to us. Okay. The slope, well, remember, slope is the same thing as the derivative. So I need to take the derivative of f of x. So the derivative of x is, well, we now know there's an exponent of 1 up here. So I'll bring the 1 down, so it's going to become 1, and then that goes to 0. So really just x becomes 1. And then the derivative of negative 2x squared, so I multiply the 2 in front, so I get negative 4. And then I reduce the power by 1, so it becomes x to the first. Now, I want the slope at a specific point here, right? I know that the x value is 1. So I know that right here, I need to be plugging in 1. So 1 minus 4 times 1 is going to give me 1 minus 4, which is negative 3. So I know the slope is negative 3, and now I can write my tangent line. Do you remember the formula for tangent line? Let me write it real quick right here in case you forgot. Y minus y1 equals the slope times x minus x1. So let's just fill that in. My y1 I already knew was negative 1, so this really becomes plus 1, right? Y minus negative 1 becomes plus 1. Okay, and then my slope is negative 3, and then I've got x minus positive 1. There's my formula. And again, don't worry about simplifying that. Leave it just like that. All right, I hope that makes some sense. I'm not going to worry about that calculator. There's some calculator stuff here. Don't worry about that now. We're going to talk about that later. But hopefully that all makes sense and you feel good with that. And I will see you on the next page.